Welcome back. In this video, I'm gonna discuss about this problem, key problem of the Codeforces around 974 in Division 3. It says that a travel network is represented by n vertices, which are numbered from 1 to n and has m edges. The ith edge connects the vertices ui and vi and takes wi seconds to travel, and all wi are even. Marian starts at vertex 1 in the market, and Robin starts at vertex n. So basically, if you see that there are n vertices, one, two, three, so until n vertices are there. Sorry, I'm not able to write properly. I don't have pen. The ith edge connects the vertices ui to vi. So let's say this is the ith edge I, and this is ui, and this is vi, and it connects this edge, and the time taken to travel this edge is given by wi. Okay, and it says that wi are even, so it doesn't we don't care that do we need to add odd plus even or why, because all the edges are even. And it says that one person is starting at vertex 1 and another person is starting at vertex n. So let's say this is the Marian. So he or she starts at vertex 1, and let's say this is vertex n, and that Robin starts at vertex n. In addition, H of the vertex, H of the n vertices has a single horse available. So it says that there are n vertices. Out of that, H of them has a horse in that vertex, and obviously H is less than n. Okay, H is less than or equal to n. And if a person takes the horse and the time taken to get on the horse is 0 seconds, that is not counted. And if the person takes the horse, the travel time is halved. Suppose the without a horse, if the travel time is going from u to v is wi, then with the horse the travel time will become wi by 2. Okay, and once a person boards a horse, and once a person boards a horse, it doesn't it doesn't die. He can take the horse as long as he reaches the goal. Okay, so that's the question. So this is the problem statement. Basically the question is, we need to find a minimum time, the earliest time where the Robin and Marian can meet at any vertices in between, right? We can choose the vertex. That's what, and we need to find the time, earliest time where the Robin and Marian can meet. Suppose vertex, if you find that vertex 1 to n reaching that itself is not possible, then we can output -1, or else if it is possible, then we need to print the minimum time. Basically, I'll explain this problem based on this sixth subtest. So in sixth subtest, it says that there are, and let me go through the input parameters. It says that we have in the first line we will get a n, m, and h, where n is the number of vertices and m is the, what was that, m? M was edges, and h is the number of horses, and how many horses are there. And next line, the second line contains the list of the vertices which has the horses placed on them. And from the third line onwards till the mth line, I mean, we are followed by m lines. We will be given ui, vi, and wi, which means that ui connects vi, and this is undirected graph. Okay, no, no, the direction is not given. You can travel ui to vi or vi to ui. Mm. And the cost of traveling, time taken to travel ui to vi or vi to ui, is wi without a horse. And that's what you mentioned here, seconds without a horse. So our job is to print the earliest time where the Robin and Marian can meet at any vertex. Okay. So let me take this last subtest. Why? Because in the till the fifth subtest, they have given an explanation. You can read through that. For the last subtest, they haven't given an explanation. So I will explain the last subtest. So we are given seven vertices and seven edges, and one only one horse, and horse is present at the third vertex. Okay, and these are the edges 1 to 5, and time taken is 2. 2 to 6 is 12, 1 to 2 is 12, 6 to 4 is 8, 7 to 3 is 4, 6 to 3 is 4, and 7 to 6 is 4. So if you look at this graph, I have formed this graph. So let us place the weight along the edges. What is the 1 to 2? 1 to 2 is 12, 1 to 2 is 12, and 1 to 5 is 2, and 2 to 6. 2 to 6 is 12, 2 to 6 is 12, 6 to 4 is 8, and 6 to 7. 7 to 6 is 4, 7 to 3 is 4, 6 to 3 is also 4. Now that one person is standing here, M, and another person is at the end of the vertex, which is 7 here, R. So both of them has to meet. Like they can meet at any vertex, but we need to find the minimum time. So what case like the output for this answer is 12. I will come to that how they have achieved 12. So before that, and we have a horse here. Okay, for marking the horse, I will just paint this. We have a horse here. If we take this thing, so basically how does the horse work? So how does the horse work? So if you cross this path from 7 to 3, it is time taken is 4 seconds. And if you take 6 to 4, without a horse it is 4, but with the horse it becomes 2. Okay, it becomes 2. And since you have taken a horse, 6 to 2, 2 will become 6 seconds. Like if you take this path, 6 to 7, and sorry, 7 to 6 to 6 to 2, it will be 4 plus 12. But if you take this path, 7 to 3, and 3 to 6, 6 to 2, what is this time? So 4 plus 2 plus 6, and since I have a horse, the time will be halved. So you can either come like this, 12 seconds, or if 12 here, and if we reach this thing, 4 plus 12 becomes 16, but we need to take the maximum time, and that has become 16. But if we take this part, 7 to 3, 3 to 6, and 6 to 2, it will become 12 seconds. And coming like this also 12, coming going like this is also 12, so answer became 12. So basically how will you solve this problem is, like take any node, apply the extra algorithm from this node to the first node, from this node to the, I mean, from the current node to the first node, from the current node to the last node. Take the Dijkstra algorithm, maximum time, like Dijkstra algorithm will give you the minimum time to reach the destination node, and you need to take the maximum of those two minimum time. That will give you the answer. If you don't have a horse, basically, since you have a horse, this problem becomes a little bit complicated. So how will you solve this problem since you have a horse? So like basically, if you didn't have a horse, if there were a version like a problem without a horse, then you will be applying the extra algorithm at 1. 1 to 1 will become 0, 1 to 7 will be something else, and maximum of that the extra algorithm for the all the nodes. Okay, but since you have a horse, you will be applying the same extra algorithm, but just create a mirror image of the graph of the, if you see the pretest past YouTube channel, he would have explained same thing. Mirror image of the graph, but like may change the vertex indices as, n plus I, means the last index is 7, right? For the first index you will be replacing it with 8, fifth index will be, so fifth index will be n plus I, right? Yeah, first index will be 8, and second index will be 9, and similarly it goes on like that. Sixth index will be 13, seventh index will be 14, third index will be 10, and fourth will be 17, and fifth will be 2, something like that. So, or you can number any number. Just you need to remember the order of it, so that you will be able to easily map it. So suppose if I n plus I, so 7 plus 1 will be 8, 7 plus 2 will be 9, 7 plus 6 is 13, 7 plus 7 is 14, 7 plus 3 is 10, 7 plus 4, 7 plus 4 is how much? 7 plus 4 is 11, so this should be 11, sorry. And 7 plus 5 is 12, not 2. 7 plus 5 is 2, 12. Okay. And wherever the horses are there, in this case there was only one horse. Let me once again what was that, once again map the edge numbers. 12 to 12, 2 to 6 is 12, this one is 6 to 4 is 8, and this is 4, this is 4, and this is 4. Okay. So, and I have written the distance as the half of it. Okay, if it is 2 it is 1. Why? Because I'll tell you why it is why, but just write the and the distance with the half of the distance. Now since we are going to take the horse, let's say we are taking the horse like traveling from 7 to 3, it will become 4. But if we're going to take the horse, just create a mirror graph and map the 3 to its corresponding node 10, which is n plus I, right? 7 plus 3 is 10, and make the distance as 0 here, and make the distance as 0. So, so make the distance as 0. Once if you see, 7 to 3 is 4, 3 to 10 is 0, 3 to 10 is 0, 10 to 13 is 2, 13 to 9 is 6. How much is that? 4 plus 0 plus 2 plus 2 plus 6. 4, 6, how much? 10. 10 plus 4 is 14. So reaching 9 is similar to reaching 2 in this mirror graph. So reaching 1 is similar to reaching 8 in this mirror graph. Reaching 5 is similar to reaching 12 in this mirror graph. So once you create this mirror graph and map this corresponding horse node to its corresponding node in this mirror graph to n plus I, and make the distance as 0, then apply the Dijkstra algorithm similarly. Find from 2, like whether it can reach, like from 7 it can reach to 2 or it can reach to 9. Both are the same thing. Like 4 plus 12, 4 plus 12 is 16. Now, instead of taking this path, 7 to 3 is 4. Instead of taking this path, it can take also this path. See, it's 4 plus 10 to 3 is 2, and 13, 10 to 13 is 2, and 13 to 9 is 6. How much is that? 6 plus 6 is 12. Similarly, coming here is also 12. Going like this in our calculation was also 12, but this becomes easier. So apply the Dijkstra algorithm from the end node to that corresponding node in ith to the ith point. Destination is I, as well as n plus I. So whichever is minimum is possible, with taking a horse or without taking a horse, that will be our answer. That's it. I'll paste the code in the comment section and you can just follow it. Thanks for watching this video. Thank you.